Hello everyone, in Unit 14 we're going to be talking about rational expressions. This is a unit that's probably one of my favorite. There's a lot involved in this unit, so if you do ever have any questions, as always, please never hesitate to email me. The first thing we want to talk about is the domain of a rational function. Now, just to explain, a rational expression is essentially a fraction. And when we have fractions, we never want the denominator to be equal to 0. If your denominator is equal to 0, then your answer essentially does not exist. Think about it. How many times does 0 go into something? Well, we have no idea because 0 is nothing. Now, I want to emphasize when you're looking for the domain, really the only part of the rational function that you care about is this denominator. So we're like, well, hey, what makes this denominator equal to 0? So, what makes x minus 3 equal to 0? What's the bad number in this case? Well, notice that if we add 3 to both sides here, x cannot be equal to 3. Because if x was equal to 3, it would cause the denominator to be equal to 0. And again, you can't divide by 0. So what's the domain? The domain is x such that x is not equal to 3. What this means, this set notation, is basically telling your reader that x could be anything under the sun. It could be negative 1,000, it could be 5, it could be 100, it could be 1,000,000. But the one number it can't be is 3. Now, steps to finding the domain, you want to completely factor the denominator. You want to make equations by setting each factor of the denominator equal to 0. You want to solve to find those bad values or those restricted values. And then the domain consists of all the numbers that are not restricted. So it's basically x such that x is not equal to what? So let's look at some examples. Now, the first step is always to factor the denominator. This can't be factored. There's no GCF. There you can't take out something. It's not 3 terms, so you can't factor using the AC method. But can you still set it equal to 0? Sure. We want to know what makes this denominator equal to 0. Well, I'll subtract 8 on both sides. 3x is equal to negative 8. I'll divide by 3. So the bad value is negative 8/3. So my domain is x such that x is not equal to negative 8/3. It can be anything it wanted to be, but not negative 8/3. Now this one's already factored. Great, wonderful. Notice I'm not even paying attention to the numerator. The numerator can be equal to 0. Wonderful, that's fine. It's the denominator that's the issue. So what makes this denominator equal to 0? Well, I'm going to set that term equal to 0. I'm going to set this term equal to 0, and I'm going to find out. Well, for this one, let's divide by 3. X could not be equal to 1/3. For this one, I'm just going to subtract 8. X could not be equal to negative 8. So the domain is x such that x is not equal to 1/3, and it's not equal to negative 8. Couple more examples. Now, look at this one. This one is not factored. So factoring is always going to be your first step. This is a difference of squares. So remember from our last unit, this could be factored into x plus 2 and x minus 2. So what's going to make this equal to 0? Well, our bad values would then be we don't want it equal to negative 2 for this one, and we don't want it equal to positive 2 for this one. Now, this one right here, look for a GCF first. There's no GCF. Then say to yourself, well, there's no number out front, so I can use that little shortcut method here and say what's going to multiply to give me negative 6 and add to give me negative 5. So we could do a negative 6 and a positive 1. So we'd have x minus 6 and then x plus 1. So what's going to make this equal to 0? X can't be equal to a positive 6 here. X can't be equal to a negative 1 over here. Now that we've talked about domain, let's talk about what it means to simplify a rational expression. So if the question asks what is the domain of the rational expression, all you care about is the denominator. Just look at the denominator, ignore the numerator. Now the directions say simplify. What that means is just like when you simplify a fraction, we want to simplify the numerator and the denominator. So step 1 is to factor the numerator and denominator completely. So y'all, if you are struggling with factoring, we need to go back a unit. Factoring is going to play a role in everything we do from this point forward. It's also going to play a role in your next math class. So make sure you know how to factor. Factor the numerator and the denominator, and then cancel out any common factors. You can cancel out multiplication, but you cannot cancel out addition and subtraction. So I'm going to show you the difference in a minute. All right, this numerator is already factored. It's just x plus 6. This denominator, however, what multiplies to give me negative 6 and will add to give me a positive 5. So let's see, we could do 6 and negative 1. So this would be x plus 6. Oh, 6. And then x minus 1. So what are my common factors? Factors are what's in parentheses here. Notice the x plus 6 are the same. Since these are being multiplied by each other, I can cancel out x plus 6 and x plus 6. Now, I've got to leave something in my numerator. Well, what is x plus 6 divided by itself? Anything divided by itself is just 1. All over x minus 1. Now, notice what I'm not doing here is canceling these 1s. See how this is x minus 1 in parentheses? That means these belong together. You can't just separate them out. The x minus 1 is just x minus 1. So unless you see another x minus 1 in my numerator, I can't just pick out pieces of it and cross it out, like the ones here. This is my simplified fraction. Now let's look at this one. 27 can't be factored. Now how could I factor this denominator here? Well, it's not a difference of squares, but I can take out a GCF. And so notice 9 is my largest number that would go into both of these. So I'm going to take out a 9, which is going to leave me 3x plus 2. So what can you simplify here? Now the 3x plus 2 belongs together. You can't take out pieces of it. The 9 and the 27 though, you can reduce down. So I could actually divide both of these by 9, which is going to leave me 3 over 1. So my final answer would be 3 over 3x plus 2. Notice I'm not crossing out these 3's because this 3x plus 2 is an entire term. This is what I meant by over here. You can cancel out multiplication, but you can't cancel out addition of these. So that's going to be my final answer. And then right here, I'm going to go ahead and factor my numerator for the sake of time. I'm looking for what multiplies to give me negative 30 and adds to give me negative 7. So that's going to be x minus 10 and then x plus 3. Down here at the bottom, what multiplies to give me negative 24 and adds to give me negative 5 is going to be x minus 8 and then x plus 3. Notice I have common terms, so I'm going to cancel those. And then my final answer is going to be x minus 10 all over x minus 8. All right, try some of these that are asking you to simplify on your own. And when you're ready, hit play to check your answer. So this first one here, we're going to factor this. What multiplies to give me negative 54, adds to give me negative 3 is going to be, that's a p. That's going to be p minus 9 and then p plus 6 all over p minus 9. So I'm going to cancel these common terms here, and then I'm just left with p plus 6 as my final answer. Notice I didn't have to put a 1 in the denominator. That's not necessary. It's only if this p plus 6 was in the denominator would you need to put a 1 in your numerator. Now this one here, what you can do is you can pull out a GCF, which would be 8, which is going to leave you 7v minus 9. All over 32v. I can't mess with what's inside parentheses, but I can reduce 8 over 32 down into 1 over 4. So my final answer would be 7v minus 9 all over 4v. And then this guy down here, I can factor this into b plus 6 and then b minus 5 all over. I can take out a GCF down here, which is going to be 3b, which is going to leave me with b plus 6. So the only thing I can do is cancel out the b plus 6's, which is going to leave me b minus 5 all over 3b. So there is a special case that we need to talk about. Whenever you have the same term that is subtraction, and the only difference is that the subtraction is written backwards, these actually cancel to give you a negative 1. So to prove to you, let's say x was equal to, I don't know, let's say 6. So if I had 6 minus 4 over 4 minus 6, this is going to give me 2 over negative 2, which is going to simplify to give me negative 1. You can plug in any number, and if all you're doing is reducing, or excuse me, you're just flip-flopping the subtraction here, it's always going to reduce to give you negative 1. So yes, these terms cancel each other, but they don't just cancel out completely, they cancel to give you a -1. So let's look at this example. This is a difference of squares, so this would be 2 minus x and then 2 plus x all over x minus 2. Now, if these had been written in the same order, you can just cross them out and call it a day. If they're written backwards in its subtraction, I will cross them out, but I'll bring out this negative, and I'm going to write my answer as -2 plus x. If you wanted to distribute the negative out, you could, but I'd rather just leave it this way. As long as you write a negative out front of your answer, then when you cancel, you've canceled these correctly. So let's get into multiplication and division of rational expressions. The steps for multiplying, you want to factor the numerator and the denominator of both fractions. You want to cancel out common factors. Now, you can cancel top to bottom, and you can also cancel diagonally. One thing you can't do is you can't just cancel 2 numerators and 2 denominators. And then you want to multiply anything that's left over. And remember, when you multiply fractions, you multiply straight across. So let's look at some examples here. Factoring is going to come into play at every piece of this problem. So I'm going to factor my numerator. So I'm going to take out a 5, which leaves me with x minus 4. I can take out an x, which is going to leave me 3x plus 1. Now, up here at the top, this is going to be using my AC method since there's a number out front. So I'm just going to come up here and show you just a reminder how you do the AC method. You multiply 3 and 4 together, which gives you 12. Two numbers that add to give me 13 but multiply to give me 12 would be 12 and 1. So I'm going to rewrite this as 3x squared plus 12x plus 1x plus 4. I'm going to split it down the middle. So this would be 3x, x plus 4, plus 1 times x plus 4. So I can rewrite this numerator as x plus 4 and then 3x plus 1. Now my denominator down here is a difference of squares. That always is going to factor in x plus 4 and then x minus 4. Sure, that's a lot of work just to get one answer. So let's see what we can do now. Again, you can cancel top to bottom like with the x plus 4s. You can cancel diagonally here and here. You can cancel diagonally here and here. Now you want to multiply anything that's left. Well, the 5 has got nothing left in my numerator, so my numerator is just 5. And the x has nothing left in my denominator, so my final answer would be 5 over x. I want you to pause this video and try this same concept on your own, and when you're ready, hit play to check your answer. So this first one, I can't factor x plus 4, so I'm just going to leave it. Now down here, I can't do anything with 3x plus 4y, so I'm just going to rewrite it. Now my numerator right here is a difference of squares, so this would be 3x plus 4y, and this would be 3x minus 4y. In my denominator, I can factor using the AC method. So I can do 2 times -20, which is -40. What adds to give me 3? I could do 8 and a -5. So I'm going to rewrite this as 2x squared plus 8x minus 5x minus 20. Split it down the middle. So I'm going to take out a 2x, which leaves me with x plus 4. I can take out a -5, which will leave me with x plus 4. So I can rewrite this as x plus 4 and then 2x minus 5. So what can I cancel at this point? I can cancel 3x plus 4y and 3x plus 4y. I can cancel x plus 4 and x plus 4. And I'm left with 3x, x minus 4y all over 2x minus 5. You can see just how important factoring is becoming because factoring now just plays one small role in this entire problem. So again, I can't stress to you enough, if you are confused on how to factor, make sure you go back and watch those videos.